Hello friends, welcome to GoodTecher LeetCode tutorial. Here we are going to solve combination sum 2 this problem this time. So I'm going to talk about this problem this time because I look at my website goodtecher.com that there's a friend called named EM leave a message to ask me to look at this coding problem. So give a collection of candidates numbers and I look at this problem description. So it's actually this coding problem, combination sum 2 coding problem. So I'm going to talk about this problem this time. So given a collection of candidates numbers C and the target number T, find all unique combinations in C where the candidate numbers sum to T. Each number in C may only be used once in a combination. So note here all numbers including target will be positive integers, and the solution set must not contain duplicate combinations. For example, given candidate set 10, 1, 2, 7, 6, 1, 5, and target value 8, a solution set is like this: array of integers 1, 7, 1, 2, 5, 2, 6, 1, 1, 6. So we notice here there are two ones in the candidate set, so they are being regarded differently. So 1, 1, 6, and also notice here there's no duplicate combinations. So 1, 1, 6, there's no more 1, 6, 1 because they are actually same combination. So if you look at this structure, solution set structure, so you might notice that this is actually like 1, 7, 1, 2, 5 is a subset of the candidate set. So this problem is actually looking for the subset of this superset. So to find the subset of the parent set, supersets, usually we use a depth first search to find the subsets. So here, in order to help you understand how to use depth first search, so I'm going to draw a picture to draw the depth first search tree first to help you understand. So first, suppose we have a candidate set that's like a 1, 3, 2, 1, and the target value is 3 for this point. So our goal is to find all the combination of this candidate set that each of the candidates, each of the combination, the sum should equal to the target 3. So in order to do the depth first search, so our first step is to sort this candidate set in ascending order. That's 1, 1, 2, 3 for its example. So you may wonder why I'm going to sort this candidate sets first. So I'm going to expand later when I draw this decision to draw this step first search tree picture. So first, remember our goal is to find the combinations to target. So we should keep remind ourselves our goal is to find a combination to target when we're doing depth first search, because depth first search we can use recursively to call this goal, like this is a function to convert a big problem to small problems so that we can keep repeatedly to use this method, this function to find to use a depth first search to find the combination. So like when we start from the empty array and we start with this point, decision point, that's an empty array, and what problem we are facing. So we have the input, that's a 1, 1, 2, 3, and our target is just a 3. So we are going to use this candidate set to find the combination to the target. And if we are keep doing depth first search to add the first value, that's a 1, and our problem is changed. Our problem is changed to the remaining candidate set 1, 2, 3, and target value is just a 2. So if we are keep going forward, so we add another element that's a 1, 1, and at this point, and the remaining candidates for here is just 2, 3, and the remaining target value is 1. So our problem is becomes smaller. So if we keep going, there's 1, 1, 2. So at this point, so remaining candidate is just 3, and the remaining target is a minus 1 minus 2. That's a just a -1. So -1 is less than the 0. So the sum of this combination is already greater than the target. We should stop. If we are not stopped, like when we add this 1, 1, 2, 3, it's even greater than this combination. So it's also greater than the target. We should not go in that way. That's why you see the reason why we are going to do the sorting first. Because we are doing sorting in ascending order, we know that when we do the depth first search, the smaller element is come first. So if at one point the combination is greater than the target, and we should stop not doing the search anymore. And when we go back, so this one we are not consider. So remove this 2 and back to this decision point, and we are going to check if there's a more 1, 1. So like the same thing happens here. So 1, 1, 3 is also greater, the sum is greater than the target. We not consider, and we go back. So 1, 1, we have finished the 1, 1 combination, and we go back to here to 1, and this is the first one with the next combination. Start with a 1, 2, 1, 2. This is very lucky, and it's recalled to the target value 3. So we should record this to the final result. That's a combination we want to save. And when we go back, so like here, also the target is a 1, 2 plus is equal to just a 3, and we should not go to this way to do search anymore. If this is way we keep doing search anymore is also greater than the target value, we shouldn't do that, because as we said, there's also sorted array, because this is already equal to target. If we add more, that's even greater than target, so we don't need to do this search way anymore. So do the next way. So 1, 3. So 1, 3 luckily is also greater than target. We not consider. We go back to 1, and we go to the, so we'll finish all the combination from the first element 1, and we will go back to the empty array and go to the next element. That's also just a 1. And we notice here, if we doing search using this way, we use a 1, 2, and that's a 1, 2, 3. So that's just a part of the first combination. We see because these two elements have the same value. So actually that means we don't need to go to this way. We don't need to consider this place. So we can directly go back. So going back to empty array and start with the next element. This would be as a start index. So that's a 2. From this way, 2 goes to the 2, 3. 2 is good, but it's smaller than, but this is greater than target, so it's not matching. So go back to the empty array and to the last element. That's just 3. 3 is good enough itself. It's just equal to target. So we should also keep record this one, keep this combination, and go back to the empty array. So we finish this depth first search. So our final results for this candidate sets is a 1, 2, and 3. So you see here that at each decision point, we are keep doing this way to find the combination of the remaining candidates set to the remaining target. So this goal, we can actually convert it to the function, to a function that we need some parameters. So what parameters we are going to have? That's a final results we need to have, and also combination to keep update with a combination, and also the candidate set. So the candidates, also the start index, like the one we are keep doing. We are going to start with a depth first search. So start index, that would be our index integers, and the next one is a target. So target is constantly changing. So every time we add a new element, and we are going to, based on that, minus that candidate value to use the remaining target value. So that's a whole process to do the depth first search. So it's just recursively to call this function. So we can go back to this coding problem to use Java to implement the coding. So as you see here, the return value would be array list of integers. So we are going to call this as a results because this is actually array list of combinations. So let's first do some exception check first. So if candidates input is an empty array, is a null or empty array, we can directly return this empty array list to the problem. And the first step we need to do, as we mentioned, we need to sort this candidates array before we going to do the depth first search, because it will help us to start with a smaller one and also avoid some duplicate search. So here we are going to have this depth first search helper function. So as we just mentioned, to find combination to target. So this function is actually just a depth first search helper function, but the way I'm going to choose using this function name, like, it's more meaningful, because when you are like in real industry, when you are doing your programming daily work, you have to name the function name properly. So you have to name it with a purpose, so other developers can understand what's the meaning of your function. So what we are going to pass, as we just mentioned, so first is a candidates and the results, and also the combination. So combination, also the start index. Start index is a 0 from the first element and the target value at the beginning. So combination, we also need to initialize. So combination would be list of the integer and combination, and it's also array list. So the whole depth first search process is happened inside this function. So after that, we can return these results, because after this function process is going to be already put all the combination to the results list. So let's implement this function. So this could be a private function, and the return is void because it just updates the results. So let's go to combinations target. So first one is candidates, and second one is list integer results. Next one is integer combination, and next one is start index, and the next one is target. This is our function parameters. So we see here, it's here, and as we mentioned, if the target value is equal to the 0, remaining target is just equal to 0, that means at that decision point we are going to have a matching combination, and we need to add this to the final result and return this function. So next, when we have a for loop here, so it's going to start with this start index, so place the element we are going to do the searching. So if it's smaller than the candidate's length, and we increase this index. So as we mentioned, if there's a duplicate, we should skip. So how can we check the duplicate? So if I is not the first one, we're doing searching, and the candidate's value is just equal to the previous one. So we can skip that, as we just mentioned. We skip this one, go to the next one. So continue to the next. And if the current candidates we are visiting is greater than the target, so what we should do? We should break, because that's a remaining target. Like we see here, if there's a 2 we add here, it would be make the sum greater than the target. So we should stop this search. Just go back to the previous state, the decision point. So it's break. So next, so we are going to, if we pass this checking, and we can add this candidates current dates to the combination subset, and after that we can start from the next index to do this, to find combinations to target. So candidates, results, and the combination, and also the start index is, and the target, remaining target is remaining target, and when we finish, we need to go back to the previous decision point. So we need to remove the name. This is the one we are visiting. It's just a combination size, so the latest element. So one thing I made a mistake here. So we need to, when we have the target value that's 0, we need to add actually a deep copy of the compilation subset. Why we are going to have a deep copy? Because this compilation is a reference to the object, so it's keep updating if we're doing this deep first search. So if we are not doing this deep copy of the value of a combination that matching to the target, we will not see, because eventually it will go back to the starting point. That's just an empty array. So we need to use a deep copy here. Let's make a quick check here, see if there's a typo. So when we start with candidates, we check error checking, exception, like edge case checking, and sort array to ascending order, and we use this combination array is, and pass it with this 5 parameter candidates results, combination 0 and target, and it should match. So with a combination 0 starting 0. So if this is a remaining target is 0, we add to the results. And for this for loop start with index. So if this is a current candidate is same as the previous element value because it's sorted, so we can skip this. And if the candidate's value is greater than target, we can go back to the, just break this loop, go back to previous point, and combination add candidate set, and to find combination to target, and candidates result combination and target. So the remaining target and the start with the next element. So combination remove. Okay, let's click submit. Oh, there's one column we are missing. Let's click that. Okay, accepted. So this is a solution for this problem. Just sometimes be careful because you may have this relative non-code and typing in a short time, and you may miss some like columns and miss typo. So just be careful of the coding. So this is all about this combination sum coding problem. I hope you enjoy watching this, and so thank you for your watching, and thank you for your subscription. This is GoodTecher. Also, as you see here, so like this, when EM leave the message, if you have some thing that some question you want to me to first take a look at, you can also leave a comment. So I'll try to look at and make video tutorials. Okay, let's make progress together. Thank you for watching. See you next time. Bye.